dissecting the mystery of egg yolk. Have you ever cracked an egg and stared at that bright yellow, round object floating among the white? Trust me, what I'm about to tell you today will make you regret ignoring it for decades. Because this simple object called an egg yolk is actually a masterpiece of biological engineering that is so perfect, so complex, and so mysterious. Today, we'll take a microscopic journey inside a laying hen's egg yolk. Let's start by discussing each one. Segment 1. Precise round shape and bright yellow color. Take a look at this egg yolk. Look closely. No sharp corners, no odd indentations. It's perfectly round. Why is it so precisely round? It's a single giant cell. It's the ovum, or chicken egg. In chickens, evolution created this super large cell to store food for the unborn chick. Segment 2. Chewy texture like Gary. Have you ever tried touching it when it's raw? It feels chewy, dense yet flexible. Why doesn't it just spill out like regular yellow water? It's composed of about 50% water, 16% protein, and 32% fat. This is where the magic of lipoproteins comes into play. These are protein molecules that love to cling to fat molecules. They act as natural emulsifiers, binding water and oil together into a thick paste. This chemical bond between water, protein, and fat creates a solid yet soft colloidal structure. Segment 3. Is the egg yolk an embryo? Many people think the yolk is the embryo's embryonic nucleus. The truth? No. The yolk's function is to provide food. It's the yolk, a giant storehouse of nutrients prepared by the mother hen for her chick. So where does the embryo reside? Look at the surface of a raw egg yolk. There, you'll find a small, pale white dot, about 2 to 3 millimeters in diameter. That's called the blastoderm, or germinal disc. That's the actual embryo. Segment 4. Brown color change under microscope, light intensity reduced. Let's look at a sample of egg yolk under a microscope. Then we lower the light intensity. What happens? The bright yellow color slowly disappears. It's replaced by a light brown shade, and in some areas, a darker brown blob appears. This is purely an optical phenomenon. When there's plenty of light, everything appears evenly yellow. But when we lower the light, it's not strong enough to penetrate the pigment-dense areas. As a result, areas with low pigment concentrations appear light brown, while areas with high pigment concentrations appear dark brown. Segment 5. Small white and light brown doubles. You see an extraordinary number of small balls. Some are milky white, while others turn light brown due to the refraction of the surrounding brown pigment. What are these little balls? These are egg yolk granules. Each small ball is a dense package containing protein, fat, vitamins, and minerals. Segment 6. The appearance of green color under the microscope. When we observe for too long under a microscope, a green color suddenly appears. This is a classic chemical reaction called iron sulfide formation. Egg whites contain proteins rich in the element sulfur. Egg yolks contain the element iron, Fe. Over time, the proteins in the egg whites decompose and release hydrogen sulfide gas. This gas then gets acquainted with the iron on the surface of the egg yolk. The result of their brief tryst is a new compound called iron sulfide. And guess what color iron sulfide is? It's green. Segment 7. Extremely thin protective coating. Look closely when observing the yolk under a microscope. Is there a very thin, transparent layer, like plastic wrap, surrounding it? And sometimes, that layer looks a little peeled or torn. That's the vitelline membrane. It looks like a very strong, clear layer. Its function is more than just an aesthetic wrap. This membrane is the first line of defense. It keeps the nutrient-rich yolk from leaking out and mixing with the egg white. It also prevents harmful bacteria from entering the embryo's food storehouse. Segment 8. Small light yellow-blue. After we see the protein granules, our eyes might catch another type of droplet. It's just as small, but a different color. It's a pale yellow and appears more oily or shiny. Is this fat? That's right. These are lipid droplets or triglyceride droplets. These droplets are pure oil enclosed in a thin membrane. Egg yolk contains about 32% fat. This fat is the densest energy source nature can provide to the embryo. Segment 9. Complete nutritional content of egg yolk. What exactly is inside? One medium-sized egg yolk contains 55 kilocalories of calories, 2.7 grams of protein, 4.5 grams of fat, approximately 185 milligrams of cholesterol, and vitamins A, D, E, K. B-complex vitamins, especially B12 and B9 folate, minerals, iron, phosphorus, selenium, and zinc, choline, lutein, and zeaxanthin. Segment 10. Benefits of egg yolk consumption for the human body. So, with such a wealth of nutrients, what are the real benefits for our bodies? First, your eyes will thank you, scientifically reducing the risk of macular degeneration and cataracts. Second, your brain will sharpen its memory and focus. Pregnant women are highly recommended to eat egg yolks for fetal brain development. Third, it maintains bone and tooth density. Fourth, it increases good cholesterol, HDL, which cleans blood vessels. Segment 11. Effects if consumed in excess. What happens if we eat too many egg yolks? First, a spike in cholesterol intake. Second, digestive problems. Third, weight gain. Modern nutritionists generally agree that 1 to 3 whole eggs per day is safe for most healthy people. Closing section. A journey from an egg into a microscopic world filled with fat globules, protein granules, vitelline membranes, and the chemical reactions of iron sulfide. So, the next time you crack an egg, pause, because what you're seeing isn't just food. It's a scientific wonder you can hold in your hands. Don't forget to like and subscribe. Leave a comment about which fact surprised you the most, and share this video with your friends who love fried eggs. See you in another exciting science exploration. Stay curious, keep learning.